So, good morning, student. Welcome back in chemistry class. So, yesterday, what were we discussing? I think we were discussing about the mole concept. That is, we were discussing about the mole concept, and very first formula what we have driven. Please tell me. That is how to calculate the number of moles. We have to calculate number of moles that is represented by n. And yesterday I told you this is given mass. Here I am writing that is what given mass, and this mass must be in grams. Then you have to divide with molar mass. Here I am writing molar mass. That we have completed this one. That is molar mass. This is the first formula to calculate the number of moles. In simple, this can be written as number of moles. Weight in which one? In grams upon what? Upon molar mass. Is that clear? So, dear student, now second formula. Here we will discuss about the second formula, that is to calculate number of moles. That is number of moles we have to calculate. Number of moles from the given particles. That is equal to given number of particles. You have the given particles may be atom, ions, molecules upon Avogadro number 6.022 into 10 raised to power 23. Are you understanding this one? Dear student, look at here. If we are given with the mass, then we have to divide by the molar mass. If we are given with the number of particles, then we have to divide by the molar particles, and molar particles are Avogadro number. That is the second formula. You got it or not? Number of moles, that is given particles. Given particles is n divided by Avogadro's number. Avogadro's number is Na. You got it? So here I am writing some of the question based on this one. Here is some of the question. That is, you have to calculate. That is, calculate number of moles. We have to calculate number of moles in number 1. We have 3.011 into 10 raised to power 20 hydrogen atoms. That is hydrogen atoms. Number 2, we have here is 6.022 into 10 raised to power 25 electrons. These are the number of electrons. My dear student, please tell me what we are finding out. We are finding out number of moles. So number of moles, here is given number of particles, that is given to me, that is 3.011 into 10 raised to power 20 divided by Avogadro's number. And what is Avogadro's number? This is 6.022 into 10 raised to power 23. Am I clear? This is 1 by 2, 0.5. That is equal to 0.5 into 10 raised to power minus 3. That is equal to, here is 5.0 into 10 raised to power minus 4. What are these? Moles of hydrogen atoms. That is moles of hydrogen atom. So dear student, please respond. Is it clear or not? I am telling you, we have to find out the number of moles. So number of moles, first of all, mass upon molar mass. Second one is particles upon molar particles, and molar particles are 6.22 into 10 raised to power. Now the second one, what we have to find out? Number of moles, and the number of moles is equal to, that is equal to, please tell me, 6.022 into 10 raised to power. How many electrons are given to me? That is 25 divided by, here is Avogadro's number 6.022 into 10 raised to power 23. Am I clear or not? So that is equal to how many moles? Please tell me. That is, these are the 100 moles of electrons. Now we have the two formula and we will club these two formula. My dear friend, I am writing here. We have the two formulas to calculate number of moles. Number of moles is equal to, that is given mass in grams divided by molar mass. This one, and second one that we calculated number of moles. Number of moles is equal to given particles upon what? Avogadro's number. Is that clear? These are only two formulas here. Now from these two formula, dear student, we can calculate the weight in grams, that is equal to number of moles into molar mass. So now we can calculate from this formula, if we can calculate mass. This is mass in grams, that is equal to number of moles into what? Into molar mass. Into what? Into molar mass. In the same way, we can calculate what we can calculate. We can calculate particles. N is equal to number of particles, and that is equal to number of moles into Avogadro's number. That is number of particles. If we have to calculate number of particles, that is equal to number of moles into Avogadro's number, 6.022 into 10 raised to power 23. Is that clear? So dear student, now if we are given with, look at here, this is number of moles, this is also number of moles. So here if we have to find out mass, that is mass in grams, so that is equal to number of moles, and number of moles we can calculate from particles, that is given number of particles upon what? Upon Avogadro's number into what? Into molar mass. Into molar mass. Okay. So students, you are talking to each other. Please respond to me. Here is, if we have to calculate mass, that is number of particles upon Avogadro number, means first of all we have to convert the particles into number of moles. In the same way, if we have to calculate number of particles from the mass, then here is mass in grams. You can write like this one. Here is mass, and mass in grams divided by molar mass into Avogadro's number, that is 6.022 into 10 raised to power 23. So please confirm me, is it clear or not? So in this way we can calculate mass of the given number of particles and particles in the given amount of mass. Okay, then let us write some question. Okay, here these are the formulas. I am telling you, we can calculate mass from the given number of particles, and we can find out number of particles from the given mass. Okay, I am starting with a simple question. That question is, here is question number 2. I am taking, you have to find out number of, that is number of moles, number of carbon atoms, number of hydrogen atoms, and number of electrons, that is number of electrons in 32 gram of methane. 32 gram of methane. So dear student, first of all, here is, first of all we have to, what we are given with? We are given with mass. We have to find out number of moles. Here is number of moles, and number of moles is equal to, please tell me, that is given mass 32 upon 16, that is equal to how many moles are there? there are the 2 moles. Someone is responding. So here is how many moles we have. Now we have to calculate number of carbon atoms. So dear student, please tell me in methane, here is a methane. Methane, in one molecule of methane, how many carbon atoms are there? There are 1 carbon atom. This means in this case, there will be 2 moles of carbon atoms. There will be 2 moles of carbon atoms. And 2 mole of carbon atom is equal to, that is equal to what? 2 into 6.022 into 10 raised to power 23 carbon atoms are there. Please respond. I am telling you, here is. Then second one, what we have to find out? We have to find out number of hydrogen atom. So dear student, once again I am asking to you, in case of methane, 1 mole of methane, here is 1 mole of methane. It has how many moles of hydrogen atom? There are the 4 moles of hydrogen atoms are there. 4 mole of hydrogen atoms are there. So then tell me how many moles we have. So please tell me. It will have in the 2 moles, that is 2 moles of methane, that will have 8 moles of, that is 8 moles of hydrogen atoms. Is that clear? Very nice. Someone responding. Now dear, next is how many electrons are there? How many electron? In case of methane, total number of electron, tell me. That is in carbon 6 electron, in each hydrogen there is 1 electron. So how many electron will be there? That is 10 electron. This is 10 electrons. 10 electrons, 10 mole of electron present in 1 mole of methane. So are you understanding? I am telling you that is 1 mole of methane. It will contain how many? That is 10 moles of electrons. 10 mole of electrons. Is that clear? So dear student, then 2 moles. This is obvious now. That is 2 moles of methane. This is 2 mole of methane. It will contain, that is 20 moles of electrons. Got it or not? So I am writing one more question. Here is, which of the following contain, here is question number 3, that is, which of following, here is, which of following contains maximum number of atoms? Here is maximum number of atoms. Number of atoms. So dear student, here I am taking, that is 46 gram of sodium. Number 2, 2.4 kilogram of carbon. Okay. Then here is number 3. Here I am taking 4 gram atoms of silver. Then number 4. Here I am taking, that is 2 gram molecule of H2SO4, sulfuric acid. Dear student, look at what we have to calculate. We have to calculate number of atoms. So one by one. First of all, we are given with, in the first option, here is 46 gram of sodium. First of all, mass has to be converted into which one? That is number of moles. 46 upon 23. Please tell me, is it clear or not? Okay, that is number of moles. Now we have to find out, these are the number of moles. Number of moles has to multiply with Avogadro's number. You got it or not? That is equal to 2Na. Na means Avogadro's number. Sodium atoms are there. Sodium atoms are there. Now number 2. My dear friend, we are given with, here is 2.4 kilogram. Kilo means 10 raised to power 3 upon 12. Are you understanding or not? That is number of moles into Avogadro's number. So this will be 200 Na atoms are there. Na means there is 200 mole atoms are there. Number 3. Here I am writing. Now dear student, for number 3, look at here. These are the 4 gram atom. I am telling you, yesterday I told you, 4 gram atom. Atoms is equal to, will you tell me? 4 gram atom is equal to 4 mole. Yesterday I told you, gram atom means mole. So these are 4 mole. So 4 mole means how many atoms are there? There are 4 into Na. Which one atoms are there? Silver atoms are there. Now dear, we are given with number 4. Number 4 is what? 2 gram molecule. Here is 2 gram molecules. And these 2 gram molecules is equal to, no one responding, that is equal to 2 mole of H2SO4. 2 mole of H2SO4 and 1 mole of sulfuric acid contains how many atoms? 7 atoms. So that is equal to 7 into 2 moles of sulfuric acid. Here is moles of sulfuric acid, or you can say mole atoms of sulfuric acid. Atoms of sulfuric acid, that is equal to what? 14 Na atoms. Na atoms. Is it clear to you? We have to find out the number of atoms. First of all, we are given with mass, that is 46 gram. In second case, we are also given with mass. In third case, gram atom is a number of moles. Gram molecules is also number of moles. So, dear student, now after that, I am on the same formula. Look at here. The second formula of the number of moles is, that is number of moles is equal to given particles upon what? Upon Avogadro's number. So from here, what we have? Particles is equal to number of moles into Avogadro's number. So, and the number of moles, these two formulas we have, is equal to what? Mass. Mass in grams divided by Avogadro's number. I'm sorry, divided by molar mass. Divided by molar mass, M. So dear friend, from here, what we have, that is mass in grams is equal to, that is equal to number of moles into molar mass. So here, this number of moles we can find out from given particles upon Avogadro's number into what? Into M. These are only the two formulas that we are discussing. Number one formula and this is number two formula. So dear student, with the help of these two formula, now we have to find out mass. I am writing here, that is question number 3 or 4. Which of the following has highest mass? Means in this question, now we have to find out mass. Dear friend, I am taking here. Number 1 is, that is 6.022 into 10 raised to power 24 carbon atoms. Number 2, that is 2 gram atom of copper. Number 3, that is 1 gram molecule of glucose, say 6, H12 and O6. And number 4, here is 3.022 into 10 raised to power 24 H2SO4 molecules of sulfuric acid. Dear student, what we are given with here is, we have to find out the mass. In the first option, we are given with, here is 6.022 into 10 raised to power 24 carbon atom. First of all, we have to be convert into the number of moles, divided by 6.022 into 10 raised to power 23. These are the number of moles. Is that clear or not? But we have to find out mass. So dear student, how many number of moles are there? There is 10 mole. Now these 10 mole has to convert into the mass. Mole into molar mass, that is equal to 10 into molar mass is equal to, that is equal to 120 grams or kilograms? Grams. Second option. If it is not clear, you may say no. So I will explain you again. So dear student, now here we have, this is mass or this is number of moles? Number of moles. So how many we have? 2 gram atoms. And these 2 gram atoms is equal to nothing but that is 2 moles of copper. Now do you know what is atomic mass of copper? So its mass is equal to, that is 2 mole into 63.5. That is, here is 127 gram. Is that clear or not? Please tell me. Now next one. Here is number 3. Please tell me, this gram molecule is a mass or number of moles? Please tell me. Here is number of moles. What we are given with? 1 gram molecule. We are given with 1 gram molecule. that is equal to what? That is 1 mole. And 1 mole of glucose is equal to, molar mass of glucose is 180. That is equal to 180 gram. Now dear, fourth option we are given with, here is fourth. There is 3.022 into 10 raised to power 24 molecules. You got it or not? Someone responding, please be attentive. So dear friend, these number of particles has to convert into number of moles. Here is 6.022 into 10 raised to power 23. So this is equal to, please tell me, how many moles? That is equal to 10 moles. But we have to convert into the mass. Now sulfuric acid, here is 10 into what? 98. That is 980 grams. So confirm, in first case it is 120 gram. In second case it is 127 gram. In third case and in fourth case. Is that clear, boys and girls? Please tell me. Very good. So this is your answer. So dear student, if you are interested in the topic, then I will tell you only two formulas are there that we have discussed. I will write again and again. Here is number of moles given mass upon what? Molar mass. And the second formula, number of moles is equal to given particles upon Avogadro's number. So now I will introduce third formula that is only applicable for which one only? Gases. Here is 1 and here is 2. Yesterday I told you, in case of gases, here is, my dear student, that is in case of gases, please tell me, 1 mole of a gas, that is 1 mole of any gas, 1 mole of any gas is equal to, that is equal to 22.4 liter at STP, and that is equal to 22,400 ml at STP. So dear friend, if we have to, we have to calculate number of moles. We have to calculate number of moles. Number of moles in case of gases, we are given with volume, that is given volume of a gas. If it is in liter, or let me write liter or milliliter, at STP, this volume is given to me at STP. So we have to be divided with molar volume. That is the third formula. Let me revise, dear student. Mass is divided by molar mass. Particles are divided by molar particles. And volume is divided by molar volume. So we can convert the given quantity into the number of moles. Am I clear or not? Here is also number of moles from mass. Here is also number of moles from particles. Here is also number of moles. I am writing this one. Here is number of moles is equal to volume upon what? And this is understood. This volume is must be at the STP divided by molar volume. Am I clear or not? So I am writing here, for example, we have to be calculate number of moles. Number of moles in, number one is, that is 56 ml of H2 at STP. And number 2, here is 2.24 liter of O2 at STP. Here is 4.83 or 44.8 ml of CO2 at STP. And number 3, that is anything you can take, 11.2 liter of CO2 we have taken, H2 or N2 at STP. So dear student, this is the simplest one. What we have to find out? Number of moles. Here is, I am writing in the first case, number of moles, it is 56 divided by, that is 22,400. These are the number of moles. And this is second one. We have to find out number of moles. Here is 2.24 liter divided by 22.4, and that is equal to 0.1 mole. And third one, here is, that is 44.8. This is in ml. So what we have to divide by? There is 22,400. These are the number of moles. And here is fourth one. This is fourth one. Here is fourth. Number of moles, 11.2 liters divided by 22.4. That is 0.5 mole. Please respond. Yes, some students, they are responding. This is just to understand, is the simplest formula to calculate. Now, one more thing here, that here, what is the molar concentration of, one more question here, I am writing question, that is molar concentration of any gas, at STP. Now will you answer me? Molar concentration is what? What is molar concentration? That is molarity. Molarity is equal to what? Number of moles upon given volume. Volume must be in liters. Now we know for every gas, 4 liter of a gas, it contains how many moles? It contains 1 mole. So dear student, what is the molarity of the gas at the STP? How many number of moles are there? 1 divided by 22.4 molar concentration. This is the molarity of gas, any gas at the STP. Means we will say that all the gases have the same molar concentration at the given temperature and pressure. Is that clear? We have 3 formulas. Now we are clubbing these formulas. I am writing first of all here. First formula is what? Number of moles, that is given mass in grams divided by molar mass, M, or you can write molar mass. Second formula is what? Number of moles is equal to given particles upon what? Upon Avogadro's number. And here third is number of moles given volume at the STP upon what? Molar volume. But it is to be remembered that it is applicable only for gases. This is applicable only for which one? On the gases. Now look at here. We can find out mass in grams. That is equal to what? And I'm telling you, these only three formulas. We can make use of these formulas and we can solve each and every question from the mole concept. These are only the three formulas. We will try to solve some question. Here I am writing mass. We can calculate number of moles into what? Molar mass. So this mass we can calculate mass in grams, that is equal to given particles upon Avogadro's number of moles into what? Into molar mass. That mass in grams we can calculate, that is equal to given volume at the STP upon what? Molar volume into what? Molar mass. Confirm me. Dear student, we can find out mass. So for calculate the mass of any substance, we have to find out first of all moles. And moles we can find out from the particles upon Avogadro number, volume upon molar volume. In this way, we can find out particles. Here is N. Particles is equal to what? Number of moles upon what? Na. Please, number of moles into what? Into Na. Now these particles, number of moles, we can calculate from mass. Here is mass in grams upon what? Molar mass. These are the number of moles into what? Into Na. Number of particles if we have to find out, that is equal to what? Volume at STP upon molar volume into what? Into Na. I am telling you, look at in the first formula what we are calculating. We are calculating mass, and in second formula we are calculating number of particles. Means if we are given with mass, first of all has to convert into number of moles. If we are given with volume, has to convert into number of moles. Then, but this is applicable for gases. Wherever we are using volume, that is applicable only for gases. Here is, we can find out the volume of a gas at the STP. That is equal to what? Here is number of moles into what? Into molar volume. Here is volume of gas at the STP is from mass in grams upon what? Upon molar mass. This is number of moles into molar volume. Here is volume of the gas at the STP is equal to what? Is equal to given particles upon Avogadro's number into what? Molar volume. These are only the formula of the number of, these three formulas are there, and you can solve all the question with these formulas. Look at here once again. If we have to find out mass, either we are given with the number of moles, either we are given with the number of particles, either we are given with the volume. Are you understanding or not? Dear, then we can, in the second formula, we have to find out the number of atoms, number of molecules, number of particles. If we have to find out the number of particles, either from mass, either from volume. So dear friend, first of all, we have to convert that into the number of moles. Once this has been converted into the number of moles by multiplying with Avogadro's number, we will get the number of particles. So please respond. Is it clear or not? And dear student, this last one, it is only applicable for which one? For gases only. You got it or not? So we have to find out volume at the STP. Either directly we are given with number of moles, either we have to be convert into the number of moles. How we will convert into the number of moles? Mass divided by molar mass. This is the number of moles. Particles divided by Avogadro's number of moles, and has to be multiplied with molar volume. Now I will take one example to distinguish. Here is calculate, that is calculate mass of. Number one is, that is 22.4 liter of H2O, or I am taking O2, gas at STP. And the second one, here I am taking 22.4 liter of H2O. H2O liquid. So, dear student, I told you, we have to find out mass. In the first case, here is mass is equal to number of moles into molar mass. Kindly confirm. Now this is gas, and we can apply this formula. Here is 22.4 divided by molar volume, 1 mole. Please confirm. This is 1 mole. Here is 1 mole. But ultimately, we have to be multiplied with molar mass. And molar mass is what? 32. This is equal to 32 gram. Please confirm yes or no. Can I apply the same formula on the H2O liquid? No, dear student. Because we cannot convert by this way. So, here is this is liquid. And for second, volume, mass is equal to, here is mass, is equal to volume of liquid into its density. Are you understanding? Please tell me yes or no. So here is, what is volume? Volume is 22.4, and for its density, it is what? This is 1 gram per centimeter cube. So dear student, my mean to say that just here number of moles, if we have a formula, this number of moles is equal to given volume upon what? Molar volume. So it is applied only for which one? For the gases. It is not applied for liquid. You got my point or not? In case of liquid, if we have to find out its mass, then has to be multiplied with its density. Is that clear? So thank you very much everyone. Tomorrow we will discuss some previous year questions related to this topic. Okay? Then bye everyone.
Good morning all of you. Yesterday we were talking about the friction, and now we will continue the same topic and little more question we will discuss, so that that concept would be clear for you. Now we are going to start. I have left with one question. I am repeating from that only, and we will continue those topics, and we will do some good questions. You will understand. Okay, so just wait and listen. The very simple question I am starting. Suppose there is one question is, yesterday we have solved this type of question. I am giving the same type of question again to you. Suppose it's a 4 kg block and mu is equal to 0.2 and its initial velocity is 10 meter per second. It's given to you. Question is very simple. Find the time after which the block will stop, and the second is the distance covered by the block. This is a very simple question. I am starting, and now it would be good if you try, definitely. Okay, so please try it. Now I am trying, now match your answer, it is going to match or not. Very simple. The initial velocity is given to you, that means kinetic friction will act, and mu is given to you, that means we have to write first kinetic friction. So for that we will make the FVD here. You will say this is a 4 kg block and there would be 4g force downward, and there would be one normal is acting here and one friction force in opposite direction, that is the friction force. And what is the friction force value? You will say mu into n. Mu is how much? Mu is 0.2 and n is nothing else 4g. You can put it 4 into g, that means that is equal to 8 Newton. That the 8 Newton is the friction force. Okay, so from that you can find the acceleration, that means retardation actually. F is equal to m into a, that means 8 is equal to 4 into a, that means a is equal to again 2 meter per second square. Definitely it is retarding, that retardation is there, that force is retardation. Now we have to put and we will get the answer. You will see from here what is the initial final velocity 0 and initial velocity is 10 and 80 we can apply. V equal to u plus 80. This is the first equation we are applying. The final velocity is 0, initial velocity is 10, acceleration is a minus 2 because it's the retardation. We can continue that with that, and this is the time. That means 2t is equal to 10. That means t is equal to 5 seconds. We can continue. The t is equal to 5 seconds we are applying. Now we have to use what is that? What is the distance covered by this particle before stopping? So we are using the second equation, x equal to ut plus half at square. X we have to find. What is the u? U is the 10. Initial velocity is 10. Time is again 5 seconds. We are applying. So 5 plus 1 by 2 acceleration, that means retardation, that is the 2. So I will put minus 2 into time is equal to 5 into 5. So from here this 2 is cancelled. This is the 50 and this is the minus 25. That means 50 minus 25, we will get 25 meter. That means before stopping, this block will cover 25 meter. Everyone is understanding? Good. Now I am starting one more question. You will understand from that, and it will give you the more idea how to solve the question, and it will actually clear a concept regarding this. Now come to the one more question I am giving you. Second example, suppose there is one block is there. It's a 10 kg block. I am taking the mu is equal to suppose 0.2. I am taking the same yesterday data, and it was moving suppose with the 10 meter per second with the initial speed, and it is having one more force acting on it, that is equal to suppose 5 Newton. Now listen carefully what I have written. Very simple. This is 10 kg. This is a block having an initial velocity of 10 meter per second, and the force acting on it is the 5 Newton in leftward direction. And very simple, mu is equal to 0.2. Now question is very simple. What is the friction force acting on it? What is the friction force acting on it? I clubbed the two concepts. First I told you in the yesterday class that if only force is acting, then how to calculate the friction force. And second question I have given to you, if velocity is given to you, how to calculate the friction force. Now I put the both together on the same block. Now we have to find. Can we solve? Yes or no, sir? Okay. Now please try. What we will apply here? The kinetic friction or static friction? What we will apply? It's a kinetic friction. Good. Now we have to continue. We have to solve this. What is the kinetic friction? So kinetic friction, we can directly say kinetic friction is nothing else mu into n. Mu is 0.2. What is the n? 10 into g. That means we can say 20 Newton. We can apply. This is the friction force acting on it. The very simple thing. Now we have to find the retardation. Yes, we can find. What is the retardation? F is equal to m into a. That means this is equal to how much? 20 Newton is equal to 10 into a. That means a is equal to again 2 meter per second square. Now before moving further, I will ask question ki where this friction force is acting, in which direction it is acting, leftward or outward? Can you answer it? Please answer it. It is moving, this friction force is acting leftward or towards right? Good. Now it is acting leftward, but my question is this is the friction, this acceleration what I have written, it is correct or incorrect? Definitely it is incorrect. Why it is incorrect? We have to understand very simple thing, because there is one force is also acting here, that is the 5 Newton. That means we have to club both forces, then only we can find the total acceleration. That means we will apply this part like this, that there are two forces acting on this. There's a 10 kg block, one is the friction force and one is the 5 Newton force, and friction force is nothing else 20 Newton we have already calculated. The total force becomes 25. That means you will say F net is equal to 20 plus 5 is equal to m into a, that means 10 into a. We can say, and now from here you can say a is equal to 25 by 10, that means 2.5 meter per second square. Understanding? Now you got the answer. This is the acceleration, that means retardation, and from that you can find the other part of the question. Got it? Good. Now I'm giving a one more question. You will understand by putting this concept. You will find this type of question in the paper also. And one more question that is also very important. Listen. Next example. Very simple. I'm putting like this. There's a one pulley is there. I'm putting one block. Suppose this is a 10 kg block, and this is a mu is equal to 0.2, and I'm putting one mass m is hanging here. Okay, this mass is m is hanging. Question is very simple. Find the minimum value of m so that system will move with a constant velocity or constant speed of 4 meter per second. The question is very simple. It is given to you, find the minimum value of m so that the system will move with a constant speed of 4 meter per second. This is the question. Now we have to find. Okay, now this question we have to solve. What is the meaning of this? That means this system is want to move with a constant speed. What is the value of speed? It doesn't matter. It may be 0.1, it may be 4, it may be 10, it may be 20, it doesn't matter. The question is very simple. Velocity or speed is constant. If speed is constant, that means here the acceleration is equal to 0. Speed constant, that means acceleration is 0. That means net force acting on both blocks should be equal to 0. Net force acting on both blocks should be equal to 0, because speed is constant. If speed is constant, what is the value? It doesn't matter. Don't worry about it. So very important thing, we have to find what should be the force. So how we can find and how we can calculate the mass from it. So for that we have to make the FBD, free body diagram. What we have to make? Free body diagram. Now try to understand how to make the free body diagram. Very simple. I'm making, this is the mass m. What is the free body diagram? There would be only one force mg downward. Upward force is only tension. That means it is not moving anywhere. That means tension must be equal to mg. Very simple. This is the first equation we have to apply. Now come to the second question, and from that you will understand one more thing. What is that? You will make the FBD of 10 kg. It's a 10 kg block. On 10 kg block, the horizontal direction there is one tension, and in a backward direction there is a friction force is acting. Because it is moving with a constant velocity, that means some velocity is there. That means this friction force would be kinetic friction. And what is the value of kinetic friction? We already know that is equal to mu into n. That means we can apply. So from here you can say mu k is equal to actually mu into n. That means mu into 10 into g, and that must be equal to the T, tension, because that is equal to the tension. It is not moving with any acceleration. Understanding up to here? Good. Now you understood from this. Now we have to find very simple thing. You will say mu is equal to 0.2. This is 10 into 10 is equal to T, and by the way T is nothing else. It is equal to m into g. That means m into g. This g is 10 is removed. What does the m become? That means that is equal to 2 kg. What is the m? That is equal to 2 kg. That means the minimum force we have to apply so that system can slide, system can move. This 10 kg block can slide on the horizontal surface. How much minimum mass is required? That is equal to 2 kg. This question, this type of question already asked in AYQ. So please try to understand, try to learn the things, you will understand. Now please answer it. You understood? Then I will move forward and I will give you some more questions related to this idea, this concept. Now I am giving related to this question, related to this idea, this concept. I will give you some more questions. You will understand about it. Okay. Now try to listen. Focus on the board. Suppose there is one table is there. On this table, and one chain is hanging. There the one chain is there. This is chain. There is one chain, uniform chain, and its mass is, total mass is m, total length is l. It is hanging, and it's a rough surface actually. Okay, rough surface. Its a coefficient of friction is mu, is given to you. Now question is very simple. If how much maximum length of this part of this chain can hang, how much maximum length can hang from this table so that the chain remain at rest, it is not falling down. What maximum length, maximum fraction of length of total chain is hanging from this table so that this chain will not fall down? That is the question we have to solve now. This is similar concept what we have learned just in previous question. Similar concept, nothing is different. What we have put, the 10 kg above and one mass m is hanging. That means this m should be like that, mg is equal to tension, and this tension should be equal to the friction force acting on the upper block, horizontal block. Understanding? This vertical block is hanging, it is having some mass m. On this there are two forces, tension and this mg downward, and the horizontal force we have putting on that 10 kg block. We have learned in the previous question, there is one tension in a horizontal direction and opposite direction, there is the friction. All should be balanced, then it will move with a constant speed or it will remain at rest because net force is zero. This is the similar thing. Now we have to put this here. How to solve it? Try to understand. Okay, so very simple thing, we have to find this length L. So total length is capital L. Total length is given to you capital L. We have to find. I am writing the question so that you can understand what is the maximum fraction of length of chain can be hanged from the table so that up to that, or we can say chain remains at rest on the table. This is a very basic question. Now we have to solve it. How to solve this question? Try to understand. Try to focus on the class. You will understand. You will learn from it. That is very important. Okay. I am repeating. Now how to solve this question? I will say कि suppose total mass is m, total length is l. Now we have to divide this chain into two parts. One is hanging, one is placed over it. Suppose the hanging part is equal to how much? Suppose small l, we can say small l part is hanging here, but remaining part would be capital L minus small l. According to, we have to find their masses. So we are writing, you will understand. Suppose this small m length, small l length is hanging here, its mass is m1. The upper part length would be capital L minus small l, its mass would be m2. Understanding? Now first we have to calculate m1 and m2, then we can solve very easily in the two lines. Very simple. First we have to calculate L1, m1 and m2. So for that I am applying the very simple concept, that is the elementary concept. Elementary concept, nothing, very simple. If you are going to the market and you want to buy some toffees, Suppose I will give you example, you will understand what is the meaning of elementary concept. You are going to the shop and you ask, "Okay, give me the 10 rupees toffee," and he give you suppose 20 toffees. 10 rupees, 20 toffee. Listen carefully. And now next time you are going to the same shop and same type of toffee you want to buy, and you are giving suppose 4 rupees. How many toffee you will get? How many toffees you will get? So that type of calculation, very simple. We have to calculate 10 rupees, 20 toffee. That means 1 rupee, 2 toffee. That means 4 rupees, 8 toffees. We will calculate. We can calculate very easily. So similarly, we will say here that total length is L, then mass is M. That means for L length, if I say from here that L length mass is M, that means for unit length, one length, that is equal to mass would be M by L. So for a small L length, how much mass would be? M by L into small. This is the mass, this is nothing else, M1. So what is the M2 mass? M2 is nothing, capital M minus M1, because total mass is capital. So from here we can say very simple, capital M minus M by small l by capital L. That means capital M is 1 minus small l by capital L. We can write this as M2. Very simple. We know this part. M1 and M2. Please answer. You understood up to this calculation. What is the M1 mass? What is the M2 mass? Yes or no? If you understood, then we will continue the question and we can solve within 2 lines. Nothing is there. Now this question is very simple. What we have learned earlier, suppose there is one pulley is there and now there are 2 blocks are hanging, and very simple I can say this is M1 mass, this is M2 mass, and there the mu is given to you. That mu is nothing else mu. We will apply right like this, and this is the mu, this is the M1. And what we have done, this block should be at rest. If this whole system should be at rest, now we have to apply it. So what is the M1? What is the M2? We have to find the relation. So we have to make the FBD again. What we have learned already. So you will say from it, sir, M1 FBD, there would be only one tension and downward is M1G. That means T is equal to M by G. Got it? The second block is there's the M2. So for M2 you will learn from it. There's a one is the M2Z. There's a one normal. There's the one tension, and in leftward action there's the friction. This is the friction and limiting condition, because maximum force, maximum length we are hanging. That means this is the limiting friction we are applying. This is not kinetic, but this is limiting friction we are applying. So we have to find this value. So what will you say? You will say limiting friction is equal to mu into N, that means mu into M2G. But that is also equal to the T, and T is nothing equal to M1G. So from here you can say mu M2G is equal to M1 into G. G is cancelled. Now put the value, you will understand that M2 value is how much? M by M into 1 minus small l by capital L, that is equal to capital M small l by capital L. This is a very simple thing. Up to here you understood or not understood, beta? Please reply. Now there is a very simple calculation. We will resolve the things and we will find the small l. Now we have to find what? M. We can remove it. Now we have to solve this question very simply. I am just writing mu minus mu into small l by capital L is equal to small l by capital. I am taking this side. This would be mu is equal to small l by capital S common 1 plus mu. That means from here I can write that small l is equal to capital L into mu divided by 1 plus mu. This is the length that is hanging from the table. Now answer it. You understood? Good. So this type of question we can find. This is a more difficult as compared to the previous question, but we can solve. Now up to here you understood or not? Please answer it. Good. Now I am giving us some different type of question. You will understand format. Now come to the inclined plane. Till now I have not introduced the inclined plane. That will give you one more idea. Now come to the next page. You will understand. The friction column related to the inclined plane. You will understand much more about it. Now focus it. When we are putting, suppose there is one inclined plane is there, and on this inclined plane one mass M is placed. mass m is placed, and if I say that this surface is a smooth surface, there is no friction. Very simple concept I am applying. If this is a smooth surface and on this block how much force is acting, you have to answer it. Can you answer how much force is applied? How much force is there? What is the acceleration of this? We have to find. The total force acting on this block we have to find. Can we calculate? Definitely we can calculate. Very simple question. Everyone know this part. Try to understand. On this block, how much force is acting? One force is mg. Another force is normal. You will take the component of this mg and the normal. You will find from it. There are two components. One component in this direction. One other component in this direction. This is the mg cos theta. And this is the mg sin theta. Now from it you will say that this block is not moving perpendicular to this inclined plane. This is moving along the inclined plane. That means motion is restricted along the inclined plane. When motion is restricted along the inclined plane, that means there is only force we have to calculate along the inclined plane. Perpendicular to the inclined plane, net force is equal to 0 because there is no force. There is no motion is there. That means normal is equal to, directly you can say, mg cos theta. This is a balanced flow. But what is the unbalanced force? That is the mg sin theta. That means net force acting on this block is nothing else mg sin theta. Understood? Up to here. Now we can apply this force and directly we can say what is the acceleration? That is equal to m into a. That means acceleration is equal to g sin theta. Very simple. Up to here. Any doubt? Okay. This is a very simple concept. Everyone knows this. There is no friction I apply. Now we are applying the friction force. One by one you will understand. You will got to know how to solve the question. Okay. Please focus on the board. Try to learn. Suppose there is a one inclined plane is there. On this inclined plane one block is placed. This mass is m. This block is placed. If I say this block is at rest, that means this surface should be rough, otherwise it cannot be at rest, because if it is smooth it will move down with the acceleration of g sin theta. But it is not moving, that means it is at rest. That means net force acting on this block should also be equal to 0. Then only it will be at rest. Net force is equal to 0. That means what is the meaning of this? Can anyone answer? Yes, you can answer. I told you in the previous class, yesterday, in that class, we know the net force is equal to 0. There are how many forces are acting on this block? How many forces? Just count the forces and please answer. How many forces? 1, 2, 3, 4. How many forces are acting on this block? Total number of forces. I am not asking the net force. I am asking number of forces. And very good. Their answer is correct. Definitely is correct. We have to understand. This is already PYQ. This is already asked. Now, what is the meaning of this? You will say, sir, one force is mg. Yes, one force is mg. What are the other forces acting? You will say one force is normal. Yes. Another force is acting. Yes. You will say the friction because it is at rest. This is a friction. We know this part. It is a friction. But what I told you in the previous class, because this normal and this friction both are the component of one single force, that is nothing else actually that we can say from a reaction force, that is the R force. That means only there are two forces are acting, that is equal to reaction force and mg. Because friction and normal are not two different forces, they are component of one single force, that is the reaction force. That means on this block only two forces are acting. What is the mg and another is reaction force. Got it? Good. Now you are understanding. That means there two forces are acting. That means this is at rest. So directly you can say reaction force is equal to that the negative of mg force. We can say, or we can only magnitude. If I want to say, you will say reaction is equal to mg. Reaction is equal to mg. Very simple. Now the second question comes to us. This is the very first question I want to know. The second question is, what is the friction force acting here? What is the friction force acting on this block? I want to know it. How we can solve that part? So try to understand. This is the block placed over it. How many forces are acting? I told you, just make it. You will say, sir, the one force is mg. Yes. One force is reaction force. Yes. There are two components. This is one friction, one is normal. Good. The mg is also having the two component. This is the theta, because this angle is theta. You will say mg cos theta, and this force is equal to mg sin theta. That means normal must be equal to mg cos theta, and from it you can say the friction force must be equal to mg sin theta. So from it, what you can say, very simply, you can say one word, that friction is equal to mg sin theta. Understood or not understood, beta? This is the friction is equal to mg sin theta. But don't make one mistake. I am telling you very clearly, you cannot write ki friction is equal to, sir, mu into n. That means mu into mg cos theta. This statement is not correct. Until unless there is one more thing is written. What is written? Ki this block is sliding or about to slide on the inclined plane. Then only this statement is correct. Otherwise, if it is only written that the block is at rest, that means it is not correct. Because at rest means static friction will act, and static friction is equal to the external force. And what is the external force? That is the mg sin theta along the surface, and that is equal to the friction. That means friction is equal to mg sin theta. It is not equal to mu n or mu mg cos theta. Now we have to continue this question. I am just asking in another form. If I ask the same question, you will understood. Suppose this question is asked like this. Next example, this is example 2. I am writing it. This is example 3. Suppose this inclined plane again. I am putting it. This angle is theta. This block, if I say this mass is m, and if I say it is moving with the constant velocity is v equal to constant. Now my question is very simple. It is given to you here mu. Mu is given, that means it's the rough surface, no need to say. Then only it can move with the constant speed. And the question is now, what is the friction force acting on this block? Now please answer it. What is the friction force acting on this block? This is a kinetic friction or this is a static friction? Which type of friction will act on this block? Please answer. I am repeating again. You will understand that this block is at rest. If block is at rest, that means net force should be 0 along the plane and perpendicular to the plane. Along the plane, how many forces? Friction and mg sin theta is acting. Perpendicular to the plane, two forces, that is normal and mg cos theta. Normal should balance the mg cos theta and friction should balance the mg sin theta. Then only it can be at rest. Good? Very simple. This is moving. If it is moving, that means motion is there. Motion is there, only kinetic friction will act. How static friction can act? That means there is a kinetic friction is acting, and for kinetic friction directly you can say the kinetic friction is equal to mu k into n. Mu is k means mu is given to you, and n we already know that is equal to mg cos theta. At this condition you can write this. It's equally correct. No problem. It's a correct now. This is mu is equal to mg cos theta. Understood? But I will tell you one more concept along with this. Now you understood. One more concept, try to understand. If this block is moving with the constant velocity or constant speed, what is the meaning? That means net force still is 0. Still the net force is equal to 0. If still the net force is equal to 0, that means we can say directly, so this is a friction, that is the mg sin theta. That means mg sin theta is also equal to friction. So here also you can say friction is equal to mg sin theta, and the very important concept is that both are equally correct. When you calculate, put the numerical value, you will find both value would be same. Mu mg cos theta is equal to mg sin theta. Got it? Good. Now try to learn. Try to understand this concept, and from that I am taking out one more concept you will learn. That means both frictions are equal. If I take it, you will learn. That means friction is equal to mg sin theta is equal to mu mg cos theta. Mg can be removed. That means tan theta is equal to mu, or this theta equal to tan inverse mu, and we call it, this is the angle of repose. Angle of repose. We call angle of repose. Understood? Please reply everyone. Please reply. I will show you this concept. You will learn what is the meaning of angle of repose. It is not much important related to the, if I talk about the competitive exam, but it is very important when we are talking about our daily life. It is very useful. I will show you. Suppose this is the one physics book I am having. This is you can understand. Suppose this is the one inclined plane is there. Okay, this is inclined, or sorry, a horizontal plane. Right now the plane is there. This is a physics book, you can see, class 11, and I'm putting this one block over it. You can see this is one block is there. I'm putting over it, you will learn. And I'm just taking this, and my right hand, which is having some beads in my hand, this hand I will take it up, and from that you will learn what is the meaning of what is the meaning of this angle of repose. So I'm putting mobile, that would be better, so that it will be more stable. Okay, now try to listen. This the mobile is placed over it. I am just taking little above. Okay, just inclined like this, like this. At this point you can see this is a sliding. Okay, I am repeating what is the use of this. Try to listen again. This mobile is placed on a horizontal surface. Now I am taking it little above, and at this angle this start to slide. That means this angle is the angle of repose. That means the minimum angle at which the block start to slide on the inclined surface. I am repeating again, the minimum angle of inclination at which any body or block or particle start to slide on the inclined plane, that angle is known as angle of repose. It is very important when you are going for the hilly areas. I will give you the idea, you will learn, and I will bind up the class after this example. When you are going to any hill area, suppose especially in the north, you are going suppose in Uttarakhand, or we are talking Himachal or Kashmir, or in northeast area also you can go, and Nagaland or Arunachal, like that. When you are going, so especially in rainy season, what this happen, you are moving on the road and there landslides are there very commonly. Why they are happening? I will tell you the very little concept about it, that is the angle of repose only. Why it is the angle of repose? When we are calculating for the sand or boulders, what is the stable angle of inclination or angle of repose is there, that is around 28 or 29 degree. That means for angle up to the 28 or 29 degree of inclination, these actually mountains are stable. But when you go to the mountain area or hill area, you will find that all mountains are having angle more than 28-29 degree, having 40 degree, 45 degree, 50 degree, like that. They are having more angle of inclination as compared to the 29. That means they are not at all stable. So especially avoid in rainy season to go to the hilly area, because that is according to the angle of repose. If angle of inclination is more than angle of repose, the block will slide down. It will not be stable on the inclined plane. And please reply. I will bind up the class today, and we will continue in the next class, and we will learn few more concepts related to the friction. I will put few more 1-2 question and then move to the power, and I will give you the next topic, power. In that, because from power also almost everywhere you will find one question. That is also very important concept. Very important. Please reply. You understood today's class or not? You enjoyed or not? Thank you. Thank you everyone. Thank you so much. Bye bye. Please. Okay. Thank you.
Hello students. Good morning. Today I came with a new lesson, that is lac operon. In regular classes also most of the students will ask the same doubts, or what is lac operon, what is gene regulation. So let us discuss that important chapter today. Then, so you will have doubts on these particular side headings. What is gene regulation? Structural gene and housekeeping gene. What are the gene regulation in prokaryotics? How it will take place? Gene regulation in eukaryotics. Structural gene and regulatory genes difference. Operon model of gene, and finally lac operon. These are the things that we are going to discuss today. Then in the last class I will explain, last slide I will explain in detail. Let us you have a look on what is gene regulation. So what is gene regulation? all nuclear cells possesses same DNA. So you have one question in NEET. All the body cells are the descendants of a single cell, that is called a zygote. And the second question in the NEET is, all sexually reproducing organisms are formed from the single cell called as zygote. So zygote, your body is made up of all the cells. Whatever genes are present in the one cell, the other cells will have the same genes. Clear? All nuclear cells possesses the same DNA, but different cells have different functions. Was it clear? The particular gene in different tissue working in different way. Gene regulation determines which genes have to be transcribed and which genes have to be stopped. So products are produced by a specific cell type. It means that all cells of the body may have the same genes, but tissue specificity will be there for every gene. Particular genes will be expressed in that tissue, and in the other tissue the gene will not express. So that is the gene regulation main concept. All genes of the cells need not to be expressed continuously. Sometimes their expression is required, sometimes exactly not required. Clear? Next, structural gene. What is a structural gene? So before going to this, let you know one thing here. So whatever the genes that produce, let us imagine this is DNA. Whatever the genes that produce mRNA and then a polypeptide. So in prokaryotic, single mRNA will be there that produce three polypeptides in like Operon. So this is called as polycistronic mRNA. The gene that produces an mRNA and a polypeptide is called a structural gene. So it is different from regulator, promoter, operator. Regulator, promoter and operator. Do you know this? Regulator, promoter, operator. So these are loosely defined as genes. Loosely defined as genes. How the textbook definitions are sometimes very beautiful. So it is not performing the function of synthesizing mRNA and a polypeptide, but they do have another duty. So repressor gene continuously produces one mRNA and then a polypeptide, that is repressor protein. So promoter gene is the site where the RNA polymerase binds. Operator, the repressor will go and bind the operator. This is secondary, I will tell you later. First, what is structural gene? A structural gene is a gene which produces an mRNA and then produces a polypeptide or an enzyme. This is called as structural gene. Clear? This is lac Z structural gene, lac Y structural gene, lac A is also structural gene. Was it clear? So structural gene, let us see the definition here. A gene that encodes amino acid sequence of a protein for an enzyme ribosomal RNA, that is rRNA or tRNA, that requires regulation. Expression of the gene is not required always in all stages of the cell life. So this is beautifully defined, structural gene. Structural gene means that is different from regulatory genes. So that gene that requires regulation is called a structural gene. How beautiful the definition is. Gene that requires regulation is called as structural gene. Clear? Then let us move to the next slide. Housekeeping gene. In contrast to structural gene, housekeeping gene is somewhat different. That is the case. A structural gene continuously have to be expressed. Structural gene sometimes expresses and sometimes not expresses. Whereas housekeeping gene have to express continuously without any break. Continuous expression. So from womb to tomb, from day one to death of your body. So the genes have to continuously work. That kind of genes are called as housekeeping genes. Whereas in contrast to structural genes, what are structural genes? Structural genes are the genes, they require particular expression at a particular time and have to be regulated, have to be switched off, switch on, switch off, switch on, switch off. That is structural gene. The gene that continuously perform its work, that is called as housekeeping gene. The genes code for constitutive proteins are constantly needed to cellular activities activities. Housekeeping genes are basically used to maintain the basic functions of the cell, that is proteins are required to build the cytoskeleton, membrane, ribosomes and other cell organelles. So could you find the difference between structural gene and the housekeeping gene? Housekeeping gene means continuously expressing gene. Structural gene means that requires regulation, that have to be switched off and switched on, switched off and switched on. And the structural gene expression is also 100%, I am telling you, tissue specific. In certain tissue that gene will express, certain tissue that gene will not express. Okay, done. You find the difference between structural genes and housekeeping genes. Now, prokaryotic gene is uninterrupted. So, prokaryotic gene is uninterrupted. This word is have to be discussed clearly. Now, if it is a prokaryotic gene, it will directly produces mRNA. Directly produces mRNA. If it is a eukaryotic gene first produce hnRNA. hnRNA. You know the definition of hnRNA. Interrupting sequences are called as introns. Exact coding sequences are called as exons. So interrupting sequence are introns. Exact coding sequences are called exons. You know very well. So this is interrupted by introns. Clear? This is not interrupted. Prokaryotic gene is uninterrupted. DNA directly produces mRNA. Eukaryotic genes are interrupted. So DNA directly produces hnRNA. hnRNA has both introns and exons. Interrupting sequences are called as introns. Exact coding sequences are called as exons. Removal of introns and reunion of exons is called as splicing. All you people knows very well, removal of introns, unwanted sequences which are useless sequences have to be removed. The removal of introns and reunion of exons is called as splicing, and gene which undergo splicing are called as split genes. So split genes, it is very clear, split genes are present in eukaryotes only. Eukaryotes only. Can you tell me why? Introns and exons concept is there in eukaryotics only, not in prokaryotics, because the prokaryotics gene is uninterrupted. Eukaryotic gene is interrupted. Interrupting sequences are called as introns. Exact coding sequences are called as exons. Removal of introns and reunion of exons is called as splicing. The process of splicing is present in eukaryotics only, and the genes which undergo splicing is called as split genes. So split gene, presence of split genes is the feature of eukaryotes. And there is a statement in molecular biology, how beautiful the statement is. The arrangement of split genes reminiscent in antiquity. So some of the students who is coming from Telugu medium or even in English medium cannot understand this line. So arrangement of split genes reminiscent in antiquity. It means that split gene arrangement is there in most ancient organisms. Most ancient organisms, that is called as archaebacteria. Clear? So split genes are present in archaebacteria also. Clear? Get back to here. Generally, control of gene regulation at 4 levels. So I am coming to the point here. So you know very well housekeeping genes and structural genes. Housekeeping genes requires no regulation. Structural genes requires regulation. They have to be switched off and they have to be switched on at certain times. This is called a gene regulation. Gene regulation. So whenever the gene function is required, then only gene have to produce mRNA. Whenever gene function is not required, they have to be switched off. So where you can switch off the genes, or else where the genes can be switched off, it will happen at 4 levels. Generally, control of gene regulation or gene expression at 4 levels. Transcriptional level, at the time of formation of mRNA. At the time of formation of mRNA, it is called as transcriptional level. So second point is processing level. What is processing? You know very well, processing or splicing or sizing or maturation. hnRNA to mRNA formation is called as hnRNA, heterogeneous nuclear RNA to mRNA. This process is called as splicing, or you call it as maturation, or you call it as editing, or you call it as processing, or you call it as different methods are there, sizing done. So that is called as processing level. Third, transport of mRNA from the nucleus to the cytoplasm. So you know very well that in eukaryotics the mRNA have to be transported from the nucleus to the cytoplasm for translation. And finally, fourth level is translation. The eukaryotic genes split into coding genes called as exart coding genes, exons, and non-coding genes, introns. Exart coding sequences are protein referred as exons. So this is secondary. We are going to 4 levels. And previous NEET question is this one. This one is previous NEET question. Most predominant site of gene regulation is transcriptional level. Beta, I repeat you once again, most predominant site of the gene regulation is in prokaryotics is transcriptional level. Was it clear? So in eukaryotics you can select all the 4. In prokaryotics most predominant site is transcriptional level. Next, primary RNA. So let us we go for primary RNA. Primary transcript means whatever the RNA that is produced directly from DNA, that is called as primary transcript. That is nothing but hnRNA. The hnRNA product contains regions corresponding to the both exons and introns. hnRNA becomes mature RNA transcript by the process of splicing. The splicing and processing introns are removed and exons are reunited. Splicing requires a special complex of enzyme that is called a spliceosome. This is 2017 AIPMT. I changed the color. Spliceosomes are absent in third option. In those days we do have only 4 code paper. I still do remember that the third option given is bacteria. So spliceosome is present in all eukaryotic cells where the splicing is present. After that, the mature RNA transported to the nucleus. Still I am not going to the lac operon. So I am telling you what are the things connected to lac operon. If you are able to understand the concepts, then finally you will understand what is lac operon exactly. Then French microbiologist Francis Jacob and Jacques Monod both have proposed the lac operon for the coordinating regulation of gene expression in bacterium, that is Escherichia coli. For the proposal of lac operon in prokaryotics, Jacob and Monod received Nobel Prize in 1965. The region is a unit of expression containing many transcriptional units which serve several genes, usually encoding proteins, refer to their functions. So now I'll tell you one thing here. So prokaryotic gene is circular, double-stranded. Prokaryotic gene is circular and double-stranded. Was it clear? Eukaryotic gene is linear. If you have one gene here, in eukaryotics, the rest of the other gene will be there very far. This is another gene in another gene. So in prokaryotics, you cannot find any unwanted DNA. I will write it as unwanted DNA. Unwanted or else or non-coding DNA. But in case of prokaryotics, you see the beauty of the prokaryotic genes. Nothing is useless. All genes of prokaryotics concerned to a particular metabolism are present at one site only. I repeat again, lactose operon 6 genes are there. One is regulator, promoter, operator, lac Z, lac Y, lac A. All are present at one particular union, one particular site only. This is called as operon. This is lactose operon. This is arabinose operon. So what is a operon means? That is equal to structural genes plus regulatory genes. together called as operants. Together called as operants. Bacterial DNA. Have a look here. Bacterial DNA. This is one operand followed by next operand followed by next operand. So what is operand? Cluster of genes. Cluster of genes required for the expression of a particular metabolism. Required for the glycolysis. You require 10 enzymes are required because 10-step reaction. And Krebs cycle, complete Krebs cycle is again 10 enzyme reaction, you require 10. All glycolysis concerned 10 genes will be present at one place only, including their regulatory sequences. Then what happens here? So together, structural genes means the 10 genes of glycolysis and their regulatory genes together called as operon, and bacteria, all the DNA having genes only. The DNA is not having non-coding sequence. All the part of DNA is coding in the form of genes only. Hence, we call it as genophore. Bacterial genome is called as genophore assertion. Reason: bacteria entire DNA make up the genes. There is no unwanted DNA, there is no useless DNA. All the DNA is in the form of genes, and that is the first feature. And the second feature is none of the DNA segment is useless. Entire DNA is useful. And the second feature is all genes concerned to a particular metabolism are present at one site only. That is called as operon. Clear? And now, so operon contains two types of genes, regulatory genes and structural genes. Regulatory gene, a gene that encodes protein molecules that go in repressor. I will tell you in detail on board itself. Promoter. So regulatory gene, leave the regulatory gene. I will explain detail. So have a look on promoter. The region of the DNA. So where RNA polymerase will come and bind. This is called as promoter. The region of the DNA where RNA polymerase come and bind is called as promoter. So next is operator. So just now I told you this is regulatory gene, LAC-I. The regulatory gene produces one protein called as repressor protein. Repressor protein will go and bind the operator. This site is called as operator. Operator gene means the region of the DNA where the repressor protein binds and regulates the structural genes is called as operator gene. Regulatory gene produces repressor protein, and promoter gene means the region of the DNA where the RNA polymerase binds. Operator is under control of the repressor. I will tell you in detail the structural genes. The structural gene means the genes that require for the production of the enzymes for lactose operon. That is structural genes. Most of the operons contain genes that encode proteins involved in the biosynthesis of amino acids, metabolism of nutrients. Operons are further classified into inducible and repressible. So this is also required. Inducible system. This is a bacterial cell. When the culture medium lactose is present outside, you know very well, lactose is a disaccharide. Disaccharide when present outside, then the genes, bacterial genes, this is, let us say, genomic DNA of the bacteria. Then to avail this lactose, the genes have to be switched on. The first, whatever the things happens, I will explain later. So the lactose is present. Lactose is a disaccharide of glucose and galactose. If lactose is present, genes have to be switched on. If lactose itself, the single lactose is called as allolactose. Allolactose enter into the bacterial cell and making just to switch on the fan. Like that, it is switching on its genes. Then it is called as inducible system. So that substrate lactose making their genes switch on, then the system, the operon is called as inducible operon. Contains genes that code enzymes involved in the metabolic pathway. Expression of the genes is controlled by the substrate. If substrate comes in, then only switch on. If substrate is not there, then it will be switched off. So substrate is making that genes to switch on, hence it is called as inducible system. And in the other case, repressible system is also there. What is the repressible system? If the substrate is switching off its genes, if the substrate is switching off its genes, that is called as repressible system. And lac operon consists of 6 genes: promoter gene, regulator gene, operator gene. So I told you already, promoter is a region of DNA where RNA polymerase binds, produce repressor, regulator produce repressor protein, operator attached by the repressor to switch off its genes. Lac Z, 3 genes are there: lac Z, lac Y, lac A. Lac Z produces galactosidase that will break the lactose into glucose and galactose, and lac Y produces lactose permease that enables that increases the permeability of the bacterial membrane to intake the rest of the lactose. And lac A, the galactosidase transacetylase, it is also hydrolyzes the lactose. These are the 6 genes are there. 3 structural genes, 3 structural, these 3 are structural, these 3 are regulating. These 3 are regulating. So I told you already, structural genes plus regulatory genes together called as operon. So bacteria, in bacteria, all structured genes are closely associated with regulators. But you should have to remember one more thing. In eukaryotic, gene is present on chromosome number 1, and this will be regulated by another gene that is present on chromosome number 20. So regulator, promoter, operator are not instant to the structural gene in eukaryotics, but in prokaryotic bacteria, all structural genes are associated with regulatory genes or regulatory elements. Next, now this is the time you required, so I will explain you in detail. Let you off. If lactose is present in the medium, first we'll go for lactose is absent in the medium. So see, have a look here. This is the bacterium, bacterial DNA. So bacterial DNA, I told you it has operons. Operon means a cluster of structural genes and regulatory elements. And if it is lactose is present outside, if lactose is present outside, so I told you, so I will expand this portion outside, this portion outside. So this is what the genes. So 1, 2, 3. Lac I, lac promoter, lac operator, lac Z, lac Y, lac A. Was it clear? So if it is present, lactose is lactose is absent. Sorry, lactose is absent. So let me have this. If lactose is absent, then what happens? This is the regulatory gene. This is the regulatory gene. It will produces mRNA and then a protein. This is called as repressor. The repressor will go and bind the operator. So whenever the RNA polymerase comes and binds the promoter, RNA polymerase comes and binds the promoter, but already repressor protein is binded on the operator, so that RNA polymerase cannot cross the operator because it's already blocked. And you should have to remember one thing: the binding of repressor protein to the operator is not completely totally, it is what do you call it as not permanent binding, exactly 2 to 3 seconds only. After 2 to 3 seconds, the repressor protein will go and loose and bind it, separated again. Again, after 2 to 3 seconds, the regulatory gene produces one more repressor will go and bind. After 2 to 3 seconds, it will fall off, means it will be detached. So here 2 questions are there. Operator is under control of regulator, clear? So promoter is under control of operator. So if operator does not allow the RNA polymerase to cross it, so that RNA polymerase cannot cross this will be the situation. Till the moment lactose comes into the medium, So always regulatory gene produces repressor protein. It is always going to bind the operator and block the RNA polymerase to move across the operator gene. So operator is under control of regulatory gene and promoter is under control of operator. Was it clear? So long the lactose is not available in the medium, the bacterial lac operon will be completely regulated, that is said to be switched off. That is said to be switched off. Clear? And come back here. When lactose is present in the medium, see situation what happens now. So this is the bacteria. This is a bacterial genes. I told you cluster of genes is called as operon. This is lac operon. I am again expanding the lac operon here. Lac operon have 6 genes: lac I, lac P, lac O, and lac Z, lac Y, lac A. Done. The first, this is the bacterial outside. First, one lactose will come. So you will ask one question here. Sir, genes are absent. If genes are said to be switched off, how lactose will go? So basal quantity of enzyme, that is called as basal quantity of the enzyme, that is permease, is present to entertain this single lactose. Single lactose will go and enter into the bacterial membrane, critical class. That single lactose not utilized by the bacterium, hence it is called as allolactose. Allolactose. This allolactose just slowly will go and enter into the bacterial cell. Was it clear? This is the disaccharide. That is why glucose plus galactose. That is why I am making like this picture. So now situation is what happening regularly. The regulator gene is producing mRNA. The regulator gene mRNA produces repressor protein. Repressor protein. So now lac operon is positively controlled or negatively controlled? Clear? This is one question. So lac operon, because the repressor always wants to switch off this, so lac operon is negatively controlled. Because the genes repressor assertion reason question. Lac operon is negative control assertion reason. Repressor always wants to bind the operator and switch off its genes. And are true, correct explanation. So lac operon is also positive. You will learn in higher studies, textbook statement. But cyclic AMP, cyclic adenosine monophosphate, will enhance the activity of transcription. Hence, it is positive control. You will learn in higher studies. So lac operon is both negatively controlled and positively controlled. Lac operon is inducible system. Earlier I was explained here, inducible system. Why it is inducible system? Lactose itself induces switch on its genes. When lactose is available, it will switch on its genes of bacteria. Hence, it is called as inducible system. And the inducer is lactose. Do remember. So, the one lactose slowly entered into this cell. So, the one lactose which is entered will go and bind the repressor. Will go and bind the repressor. So this repressor protein, after binding with this repressor protein, the repressor protein, after binding with this lactose, after binding with the lactose, so it cannot have it will change, it will have some conformational changes. It will have some conformational changes. It cannot go and bind the operator, cannot go and bind the operator. So that promoter is free. Then what happens? Instantly RNA polymerase will come. I have taken green RNA polymerase now. RNA polymerase now what it does is RNA polymerase will cross the operator because repressor is bounded by lactose. Then repressor became inactive after getting some structural changes. Promoter crosses the operator and synthesizes single mRNA. What do you call it as? Polycystronic mRNA. So lac operon produces polycystronic mRNA assertion reason. One mRNA produces more than 2 polypeptides, that is called as polycystronic. So lac Z produces galactosidase, lac Y produces permease, and lac A produces trans-acetylase. Clear? So now what are the functions of the galactosidase? First you have to discuss about the function of the permease. What is the function of the permease? Permease will entertain the lactose, further lactose molecules will enter. Name itself shows what is permease. Enhances the permeability of the bacterial membrane for lactose. So remaining lactoses, all lactoses will come in. First lactose, yellow color lactose, I call it as allolactose. Okay, that is not metabolized, that is not utilized, that is not broken into glucose and galactose, hence it is called as allolactose. When permease is synthesized, the remaining lactoses will enter into the bacterial cell. So what is the function of the permease? Permeability increases the permeability of lactose. So now the next function of the galactosidase, it will break the lactose into glucose and galactose. Glucose and galactose. Galactose later converted into glucose, again the same will be there. And trans-acetylase, acetylation of glucose, but in textbook it is mentioned that whose function is not known. Whose function is not known, you remember like that only. What is the function of permease? Increases the permeability. What is the function of the galactosidase? Break the lactose into glucose and galactose. And the trans-acetylase, whose function is not known. So this is when lactose is present in the medium. One lactose will go and open the door. Open the door means go and bind the repressor. Repressor cannot bind the operator. Operator is free. Then the genes are transcribed and the product is produced. This is all about lac operon. So do you have any doubts in lac operon? First of all, I'll ask some questions to you. What is operon? A cluster of structural genes as well as regulatory elements. But point number one. So, what are the questions can be asked here? Lac operon is completely polycystonic mRNA. It produces polycystonic mRNA. Assertion. Reason. One mRNA produces more than one polypeptide, that is called as polycystonic mRNA. Was it clear? Second question. So what is which of the following genes constitutively express? So here the question is which of the following genes are constitutively expressing, means continuously expressing, that is lac I, lac regulatory gene, always produces repressor. And the question number 3 is the binding of the repressor to the operator is permanent or tentative? This is absolutely tentative. Was it clear? These are the questions related for lac operon. Lac operon is another question appeared on the same concept. Another question appeared on the same concept is operon model of gene regulation. Operon model of gene regulation is applicable to. So operon model of gene regulation is applicable to. I will give you the options also. The options are prokaryotics only, eukaryotics only, all living organisms, all microorganisms. So these are the 4 options given. Operon model of gene regulation is applicable to prokaryotics only. Can you tell me the reason? The operons are present in prokaryotics only. Then you will have a next question. What is operon? What is operon? Cluster of structural genes and the regulatory elements together called as operon. If operon is present in prokaryotics, then operon model of gene regulation is applicable to prokaryotics only. Clear? Clear? Then another question. If what happens if lac promoter is mutated? what happens, so let probably leave this genes, what happens if lac Z is mutated? If lac Z is mutated, what happens? Tell me what happens. I'll give you two options. Lactose cannot enter into the cell. Lactose cannot further divided into glucose and galactose. What happens if lac Z is mutated? If lac Z is mutated, then galactosidase is not formed, so that there is no breaking of lactose into glucose and galactose. Was it clear? These are the previous questions asked on this lac Operon concept. This is the most important chapter of molecular biology, that's why I have taken this chapter. I hope you may have doubts. Text the message and I will see that message, and whatever your doubts are there will be explained in the next class. Thank you very much. All the best. Have a good day.
Good morning. How are you all doing? Today I like to give a brief detail about the three phylums. I'll try. That is Annelida, the Arthropoda and Mollusca. The phylum Annelida this is being named from the term annulus, means a ring. The body has ring-like segments. That's how the phylum is named. This phylum has, for the first time in the animal kingdom, certain characters have developed for the first time in this phylum. That is, this is the phylum to develop metamerism. This is the first phylum to develop real coelom. This is the first phylum to develop circulatory system. Right? These are the three things that have appeared for the first time in the phylum. Now, what do you understand by metamerism? Metamerism means the linear repetition of some of the internal organs in the different segments of the body is called metamerism. Metamerism is a linear repetition of some of the internal organs in the body of the animal is called metamerism. That is there in only three phylums. One is Annelida, second one is Arthropoda, and the third is Chordata. These three phylums show metamerism. Real coelom can be called as eucoelom. Real coelom means it is also called as eucoelom. So from Annelida onwards, you will find the real coelom appears. Before this, you have the phylum called as Helminthes has false cavity called pseudocoelom. Platyhelminthes is without the cavity, right? So the word "eu" means true. EU literally means true. As you know, the scientific terms we derive from either Greek or Latin. They are not English words. So EU literally means, the literal meaning comes as the true, right? So the true coelom appears here, and you also have circulation that is of closed type, mostly closed type. If they give you a statement like all annelids have closed type of circulation, then it is wrong, because we have exception. Exception is leeches. In leeches it is open type, but remaining all other groups you will have closed type of circulation. So these are the three things that have appeared for the first time in Annelida. Okay. Other than this, you come across the structures being called as Annelida has both circular as well as longitudinal muscles. The earlier phylum, that is Aschelminthus, it has only longitudinal muscles, they don't have circular muscles. So annelids have both longitudinal and circular muscles are present in this group. Okay, and they have speciality related to the locomotion. Locomotion may takes place with the help of CT. They are also called key teeth. The setae, they are made up of chitin. That's why they are called as the chitinous, right? Chitin, as you know, it's a polysaccharide. So either it is made up of the chitin, they are structure that will be providing anchorage. What is anchorage? Anchorage means they provide the grip, right? So that you know they can hold the surface and the organism can move forward, right? And they have structures called suckers. Like for example, in case of leeches, you find the suckers will be helping in attaching to the host as well as to the surfaces where it will be helping in moving. And Parapodia, like in case of Nereis, these structures will be helping in the locomotion as well as they help in respiration. So Parapodia, not only they help in locomotion, but they also help in respiration, they help, right? So that is speciality related to the locomotion in the organisms. Then digestion is said to be complete. What do you understand by complete gut? Complete gut means the animal that are having both mouth as well as anus. Right? For example, if you take Platyhelminthes, they have only mouth, they don't have anal aperture. So there the gut is said to be incomplete. But here from Aschelminthus onwards, you will find both mouth and as well as the anus is being present. That's how it is called complete. And they have the respiration is with the help of body wall. Body wall and Parapodia will help. This is not mentioned separately, but you need to understand because the diagram is given for the Nereis. So it may be asked related to respiration by Parapodia. And circulation is closed type, and here organisms they have blood is having a respiratory pigment. Blood carries the pigment, blood is colored. For example, if you take earthworm, the blood is red in color. But surprisingly, there is no RBC. Okay, earthworm, the blood is red in color, but there is no RBC, right? So this is because the hemoglobin is present in plasma. Hemoglobin lies dissolved in plasma. Hemoglobin present in plasma is a non-choroid character. Hemoglobin present in RBC is a choroid character. So wherever you will find the hemoglobin is or the hemocyanin or chlorochlorine, they all will be present in plasma. They are not present in RBC. That is one non-choroid character. You need to remember this also. And when it comes to the excretion, we go for the new page. When it comes to the excretion, we have structures named as nephridia. Nephridia are the long tubular structure that will be opening into the coelom or the body cavity, right? And from the body coelom or the coelomic fluid, as well as from the blood, they collect the waste and they send them outside. Okay, so these are the long tubular structures helping in maintaining excretion, as well as the primary function is osmoregulation, that is maintaining the salt and the water balance. And when it comes to the nervous system, it is mentioned there as it contains paired ganglia. For example, say these are the paired ganglia. These paired ganglia, they are connected to the double ventral nerve cord. Say this is the double ventral nerve cord. Ventrally, the nerve cord is present and it is a pair, that's why the double ventral nerve cord, with the help of transverse nerves. I will be using this color to indicate they are being connected here with the help of the lateral nerves. These are the lateral nerves. So with the help of the lateral nerves, it is connected with the nerve cord. Okay, so if you can remember this diagrammatic structure, you can get the how the nerves coordination is there in Annelida. Sense organs are poorly developed, or they have the structures as receptors, and related to reproduction, animals are mostly bisexual. Animal like Nereis is unisexual. Unisexual, as you know, it is dioecious. Peritima and leeches, they are bisexual. Right? In case of unisexual, development is indirect. In case of bisexual, development is direct. Unisexual will have indirect development through the larval form, whereas bisexual they will be developing directly. So you got three examples. The two are there diagrammatically called Nereis or the Neanthus, and the leech called Hirudinaria along with Ferritima. Okay, that's about the Annelida, the phylum, which is having the dermomuscular body wall. So in this, the circulatory system has appeared for the first time, metamerism has appeared, and they are real coelomates, along with the two different kinds of muscles called longitudinal and circular have appeared. Okay, and the phylum called Arthropoda, this is having the literal meaning. Arthro means joint, podus means appendages or foot. So animals are having jointed appendages. This is said to be the largest phylum. That means around 2/3 of the known species, or the species that we are able to discover, they all come under this phylum. Now, how the organisms are able to lead a successful life? How arthropods could dominate? They could dominate because one reason, they have chitinous exoskeleton. the body is covered by a chitinous exoskeleton which is impermeable to water. Chitin is impermeable. So that means the exoskeleton is able to prevent water loss. So naturally organisms can survive in any kind of habitat because they are not going to lose the body water. That's one reason. Another reason is jointed appendages. Jointed appendages will be providing flexibility. Organisms will remain quite flexible and they will be able to escape easily from the predator, and they will be able to carry out also the locomotion much faster because of jointed appendages. These are the main reasons. Other reasons like appearance of striated muscles. Okay, the skeletal or the striated muscles have appeared for the first time in arthropods, and the other structures also help, but these are the main reasons why they could lead a successful life. In this phylum, body is divided into functional regions. Body gets divided into functional regions. The regions are named as tagma. Like for example, head region, thorax is one region and abdomen is one region. So head is one tagma, thorax is one tagma, abdomen is one tagma. They are not segments, right? They are not segments, they are actually the regions made up of different segments. For example, if you take cockroach, head is made up of 6 segments, thorax is made up of 3 segments and abdomen is made up of 10 segments, right? So this kind of division of the body into the functional regions is named as tagmosis or tagmatization. That's not required, you just remember the regions, they are functional regions, okay? And in this phylum, we will be learning in detail about the structures related to respiration, and it focuses on excretion. Respiration, as you know, it is carried out with the help of tracheal system. Like in case of insects, insects will have highly branched tracheal system where oxygen or the air directly goes to the tissues, because blood is colorless, blood cannot transport oxygen here. So oxygen directly reaches all the body structures through this highly branched network called tracheal system. In case of scorpion, you find special structures named as book lungs. Book lungs are the respiratory structures in scorpion. In case of aquatic animals, right, for example say the prawn, you will have gills. So we have a class in Arthropoda called crustacea. This is a class, and this class has example like prawn, crabs, lobsters. They all have gills as the respiratory structure, and book gills are the respiratory structures in case of limulus. In limulus, book gills are respiratory structures where the animal is also named as the horseshoe crab or the king crab, This is also an example for living fossil. That's about the specialty in respiration. And when it comes to the excretion, excretion in this phylum is also special. It is with the help of the Malpighian tubules. In case of insects like cockroach, it is with the help of green glands or antennary glands. In case of crustacea or prawns, crabs, lobsters, they will be carrying out the removal of nitrogenous waste through antennary glands or the green glands. Okay, and these two are special in this phylum. And when it comes to the nervous system, nervous system is formed by the nerve ring and double ventral nerve cord. This is common right from Annelida. Arthropods are special by having well developed sensory structures when compared with annelid. Annelids, like only in case of Nereis, they may have tentacles and eyes, but other animals they don't have the structures. But in Arthropoda, we have sensory structures being seen, like you will find here. You are able to see here sensory structures like simple eyes, compound eyes, they have antennae, and they have structures named as statocysts. Statocysts are balancing organs. You should remember this. The balancing organ, they are there right from Cnidaria onwards. In Cnidaria, as you know, they have two different forms called polyp stage and medusa stage, right? So polyp is sedentary or sessile, whereas medusa is free swimming. So medusa have these statocysts as the balancing structures. That is the nervous system. And in the reproductive system, animals are dioecious or unisexual. Fertilization is mostly internal, and development includes both direct as well as indirect development, both are seen. So in this phylum, you need to remember the examples. You come across examples which are economically important. You come across the examples which are causing diseases, right? So economically important, I will mention here some of them. Economically useful, like honeybee is called as the apis, and silk moth is called Bombyx mori, and lac insect is called Laxifer. Honeybees, silk moth and the lac insect, these are all useful insects. Mosquitoes are spreading diseases, like we have Anopheles spreading malaria, Culex is spreading filariasis, and Aedes mosquito, this is spreading dengue fever and chikungunya. Okay, chikungunya, dengue fever, they are being spread by Aedes mosquito. Culex will spread filariasis, right? So these are the three harmful. Beside these, we need to remember about the example of scorpion which we discussed. You have the diagram of the gregarious pest We have an example called gregarious pest. This is also important. The animal called Locusta. Locusta is a gregarious pest. Gregarious means they move in very large numbers and they cause lot of damage to the crop. Within a short period, they can make the plant leafless or they can make the plant naked. Right? So that is the organism or the insect called as the Locusta, which is a gregarious pest. So this is the dominant phylum called as the Arthropoda, the most successful phylum because the animals are able to protect themselves with the help of the chitinous exoskeleton, jointed appendages, striated muscles, well developed sensory structures, and most of them are having the direct development. Some of the insects, they have indirect development, right? And when it comes to the phylum Mollusca, this is derived from the Greek word called mollis, means soft. So this will include soft bodied animals. This is the second largest phylum. So most of the animals are aquatic and marine, some are freshwater, and you can also find terrestrial, like for example snails, right? Snail is terrestrial, but otherwise mostly they are marine forms. So these organisms, they have their body being divisible into three regions called as the head region, visceral hump, and a strong muscular foot. Body is divisible into the head region, visceral mass. What is viscera? Viscera means the internal organs. All the internal organs will come together and they form a hump. You understand hump, no? Like this, it will form a hump-like structure. They have a strong muscular foot. This is, say for example, the alimentary canal and the others, which will form the visceral hump. And the animals are provided with a calcareous shell. The body is protected by a shell made up of calcium carbonate, right? Now this visceral hump is covered by a soft layer called as mantle. The red line I am drawing here, this is the soft layer that covers the visceral hump, is named as mantle. So presence of mantle is unique to the phylum. Mantle is seen only in Mollusca. Okay, mantle is a soft layer that will be covering the visceral hump. So in between the visceral hump and the mantle, you will have a cavity here. Between the mantle, this also you need to remember, this is the narrow space present between visceral hump or visceral mass and mantle called mantle cavity. Okay, mantle cavity is not present between the shell and mantle. Mantle cavity is present between the visceral mass and mantle. So opening into this mantle cavity, you will find alimentary canal opens through anus. Gills also will open into this mantle cavity. Excretory structures also will open into this, and also the genital ducts also will open, right? The undigested waste will be released into the mantle cavity. From there it is sent outside. Similarly, the gills will be opening there into the mantle cavity, and also the excretory structures which are being called as the kidney opens also into this mantle cavity. Genital ducts means if it is a male animal it is the vas deferens, and if it is a female animal it is the oviducts will open here, so that eggs are released into mantle cavity. From there they will be sent outside, right. So this is the three regions and the importance of the body in mollusca. When it comes to digestion, mouth will be leading to the buccal cavity or the buccal chamber. This chamber has a special structure called as radula. Buccal cavity has a special structure named as radula. So in the phylum Mollusca alone, you are able to see the structures named as mantle and radula. You don't find these two structures in any other animal group. These two are unique to the phylum, right. So radula is one rasping organ. Rasping means it will be cutting the food material. Food will be cut into small pieces with the help of radula, right. So the radula lies in the buccal chamber, helping in cutting the food material. That's speciality in digestion. Respiration takes place with the help of gills. Gills in case of molluscans, they are named as Ctenidia. Gills in mollusca, they are feather like or comb like, right, and they also will be helping not only in respiration, they also help in excretion. This is an interesting property. Gills in mollusca, they help not only in respiration, they also help in excretory process, removal of nitrogenous waste, which are feather like or comb like structures, or they are also named as Ctenidia. If you can remember, this is the additional information. Gills are also named as Ctenidia only in case of mollusca because of the shape, okay, because of the shape they are named as the Ctenidia. And excretion is with the help of the kidney. It is also called as organ of Botany, okay, or the Keeper's organ will be helping in removal of the waste material. Circulation is open type. Nervous system is developed here with the help of ganglia, and you also find sense organs in the form of eyes, tentacles are being present. The head in the body has sensory structures in the form of eyes. Head also has tentacles acting as sensory structures in the group, and body is protected by a calcareous or calcium carbonate shell. It may be external or it may be internal, or some of the case the shell may be even absent. Like for example, octopus it doesn't possess shell is absent there. So these are the important characters of this phylum. And reproductive system, animals are unisexual. Unisexual is called dioecious. If you have confusion related to the uni and bisexual or unisexual, try to get one, you leave the other. Unisexual is dioecious. So this di has no relation. Don't think that unisexual means monoecious. Animals are oviparous and they have both direct as well as indirect development is seen in this group. That's special in case of the mollusca, where you need to remember that the animals are divided into the three regions called head, visceral hump and foot, and these two are the unique characters called radula and mantle only in mollusca, and gills in these animals will be acting also as excretory structures. These are special for the phylum, and circulation is open type. Okay, and you have a list of examples. You have list which is not familiar to us. These are all the names which are somewhat different names along with the common names. You also remember need to remember the common names. For example, phyla, this is called apple snail. You also have diagram of this animal. You have diagram of octopus. This is called devilfish. What is special about the devilfish? Here, octa means 8. You may be knowing, no? Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Isn't it? Octa means 8. Here, the foot is modified into 8 arms. This animal is special where shell is absent, right? Octopus eye works like vertebrate eye. Octopus eye will function like a vertebrate eye of the human eye, right? So, are they homologous or analogous? That means functionally same. Octopus eye is functionally similar to the human eye. Are they homologous or analogous? I can respond. And octopus is devilfish where it is having the strong arms with suckers. You have pearl oyster called Pinctada. Pinctada is called pearl oyster. We get pearls from them. Example like the sepia. Sepia is called cuttlefish. Okay. Similarly, we have the animal called dentalium. Dentalium, the shell will be looking like elephant tusk. That's why this is called the tusk-shelled animal. You have Chaetopleura. Chaetopleura are commonly called as the chitons. Aplysia, this is commonly called the sea hare. These are all the examples given in NCERT. We need to go both scientific name as well as the common names are to be remembered. Both are important. So generally for the examples they will be going for the scientific names. Sometimes they may also give you the common names. Okay, so you should remember both these terms. So this phylum gets you the names. These are not familiar to us, so better you write and read number of times so that you will be able to get those names. Okay, that's about this phylum being called Mollusca, which is special by having the radula, mantle, gills. Right? So gills are special by having the property or the function of, besides the respiration, they also help in excretion. What is special in case of Arthropoda? Jointed appendages, the largest phylum. Then you will have the chitinous exoskeleton, development of sense organs. They have modified structures for respiration, excretion, right? And along with that, you should remember the example. Annelida is special where they developed for the first time the metamerism or segmentation. They have developed the real coelom and they developed the circulation, right? So these are mostly the vital characters or the important characters related to the group. And the next group is Echinodermata. Echinodermata is special by having the special system called vascular system. It is not canal system. Don't confuse with canal system. Canal system is different. This is called vascular in Echinodermata, where the seawater is circulated through the special canals derived from coelom. So that system will be helping in capturing food material, helps in locomotion, helps in respiration, helps in excretion, right? Those are the functions carried out by vascular system. And the phylum is named as Echinodermata because the body is spiny in appearance. The spiny appearance comes from the ossicles, which are derived from ecodon. There is also one special character of the phylum. Okay, we will discuss. The time may not permit us to go in detail about that phylum, right? So we got some idea about the, or rather almost the complete idea about the phylums called Annelida, Arthropoda and Mollusca, right? Annelida is special by having the first time development of metamerism, real coelom and circulation. Arthropoda goes special by having the largest phylum along with development of chitinous skeleton and the jointed appendages along with specialized respiratory and excretory structures with sense organs. Mollusca is special by having these radula and mantle being unique and gills helping in both respiration and excretion, right? So if at all any queries, you can message us so that we can clarify them in the coming classes, right? Okay, thank you, have a good day.